In this video, we're going to talk about future worth analysis, which is an alternative to present worth. So by this point, we've talked about finding P and finding F and finding A, and this is really no different, except now we are talking more about applications and how this affects decision making. So in the past, we've just kind of used these formulas to find these numbers, and now we're going to actually make decisions based off these numbers. So we've talked about present worth, and in this video we're going to talk about future worth. So what is future worth? It's very appropriate because sometimes what we're trying to do is maximize the future wealth of the owners of the firm. Although present worth continues to be the most used tool, future worth is also used, and it has benefits. There's benefits to using future worth. So future worth is based on the equivalent worth of all cash inflows and outflows, but at the end of the study period at an interest rate that is generally the MAR. We've talked about this in the past, and in case you don't remember, MAR stands for minimum attractive rate of return, and this is a rate that we use in our analysis that is based on what the company has decided, and this MAR can be found through a number of calculations involving how else can the money be invested and what is the minimum rate that is worth me using, because if I don't use it in this, then I could find another project that could give me at least that kind of return back. So this is very useful to decision making, because if something, for example, a future worth, if we find a number that given the MAR is negative, then that's a bad investment. So let's look at this. Oh, and by the way, if we do present worth or future worth, the numbers will be different, but the decision we reach should always be the same if we do it properly. So we're going to do a couple of examples. This one says a $45,000 investment in a new conveyor system is projected to improve throughput and increase revenue by $14,000 per year for 5 years. The conveyor will have an estimated market value of $4,000 at the end of 5 years. Using future worth and a MAR of 12%, is this a good investment? So first of all, as usual, we want to draw our little cash flow. So our little cash flow, I'm going to draw it one here. 0, 1, 2, 3, 4, 5. So it's an investment of $45,000, so it goes down. It's an outflow. And then we will be receiving benefits. Now, not in cash necessarily, but they're going to increase revenue. Sometimes they increase in savings, but in either case, we do point our arrows up, and this is an A equal to 4,000. And finally, this thing, and we've talked about this before, this is this extra 4,000, when it says estimated market value of 4,000 at the end of 5 years, this is a salvage value. So that's on top of the 4,000 that were already there. And what this is an amount that we can get back for selling whatever was left of our equipment. So how do we calculate future worth? Well, future worth is going to be equal to, now when we calculate worth, we are actually, any outflow should be negative and inflow should be positive, unless we're calculating just benefits or just costs, in which case everything would be positive. But when we have both, it's a good rule of thumb to do negative for the outflows, meaning arrows going down, and positive for the inflows, arrows going up. Oh, and by the way, this is not 4, this is 14, right? Yes, sorry, I had that wrong. Okay, so this is negative 45,000, F given P, 12% for 5 years, plus 14,000 F given A, because this is an annual amount, 12% for 5 years, plus 4,000. Now, why are we not multiplying 4,000 times anything? Because this is already in F. So it's already at the end of year 5. Okay, so if we find these numbers in our tables, in our compound interest tables, and if we finish this formula, if we do this calculation, we find that the future worth is equal to 13,635.7. It's a positive number. It is a good investment. Okay, great. We have this example right here. This one's based out of a cash flow. And here, although it says I wanted to make sure that it is clear for this problem that we're going to find that this is a MAR. So let's say that this is an investment, or not an investment. Okay, so I'm going to add information to this cash flow, and I'm going to say that I'm going to make an investment of I don't know, let's say 100. Okay. So how do we set this up? Now, there's several ways to do this, and the reason I chose this example is because it's actually good practice for showing the different options that we have when we move money over. So at the end of the day, what we want is to know the future worth of this, and we can use a gradient here, and then so this can be a G, and this can be an A, or we could include that 30 with the A and finish the G right there. So I'm going to choose to do the option that I did first. So let me erase some of this stuff. And the way I'm going to do this, and I'm going to continue in the next slide with actual, with the rest of the formula, but here I'm going to have that F is equal to, now we don't have F given G, so what I need to find is, I'm going to choose to do, let's see, these together, and actually I just changed my mind. I'm going to do that. Okay, so about this, I need to find P first, and then F given P, just because I don't have F given G. So F is going to be equal to, first of all, 30, F given A, 10% for 6 periods, right? 1, 2, 3, 4, 5, 6. And now it doesn't matter that those periods are at this point, since we're looking for this, and these are immediately and finishing in that place, then this is a perfect candidate for just a simple F given A. And then plus, this is 5, P given A, 10% for 5 periods, plus 5, P given G, 10% for 5 periods. And remember that that's how we calculate gradients, but we need to multiply this times F given P and send this. So what we did after we finished this is we were actually, our equivalent P is always placed one period before, like here. So we're finding P right here, and then we're sending this P over here. Now I'm making a mess, right? But F given P, 10% for 11 years, right? From 0 to 11. And then minus this 100, F given P, 10% for 11 periods. Okay? So let's go off to the next slide so we can finish this. Okay, so this is equal to 30 times 7.7156 plus 5 times 3.7908 plus 5, 6.862 times 2.8531 minus 100 times 2.8531, and this is equal to, let's see, I'm sorry, I have my calculator out. I didn't have the final number. 2.85. 0.31. I'm almost done. So this is actually equal to 97.69. So barely, but it is a good investment. At least it gives me a positive number. Not a very high one, but something. And remember, this is future worth. It doesn't mean that that's an exact amount of money that's going to come into my pocket. It's just telling me the worthiness based on my estimates right now. Great.